Let's summarize this particular chapter, conic sections. Now see, when we are trying to summarize, remember conic sections, it's a part of a cone. Depending on how you are going to cut the cone, you are going to have different sections, isn't it? So at first, we are going to start with circle. All right. See, for a circle, you have the equation x square plus y square is r square. Then for that, the center is the origin, 0, comma 0. They have a radius of r. In the sense, you are going to have the x and y axis, and you are going to have a circle like this. Correct? The next one is a more general case where you have x minus h whole square plus y minus k whole square is equal to r square. Where if you have the x and y axis here, the circle is going to be somewhere over here. The center is h comma k. And the radius is going to be r itself. There is no change in that. Correct? This was the first type of a conic section what we discussed. We solved the problems based on this one. Finding the center, finding the radius, everything. Okay, so this is the first part of a conic section. Let's discuss the next one now. Okay, let's summarize the next one now. See, for the next one, what you have, it's going to be a parabola. See, a parabola is that type of a conic section where the point is moving in such a way that the distance from the fixed point and the line is the same. Correct? So there are four types of parabolas. You guys know that. See here the equation, vertex and everything. If the equation is y square is equal to 4ax, then the graph, see the graph is going to be like this. Side opening graph, isn't it? So for side opening, vertex is 0, comma 0, which is basically the origin, 0, comma 0. Then we have the focus, the point on the x-axis, which was a, comma 0. Then the latus rectum, length of latus rectum is what? So it's the perpendicular line to the axis, which is passing through the focus, isn't it? So latus rectum becomes 4a. And the axis is going to be x-axis. In the sense, y square is equal to 4ax is symmetric about the x-axis. Correct? The next type of parabola, x square is 4ay. So this one is going to be an up opening parabola like this. Again, the vertex is 0, comma 0. Focus is 0, comma a. It's on the y-axis. Then we have latus rectum and the axis of symmetry. Same thing goes for the next two. Y square is equal to minus 4ax, x square is equal to minus 4ay. So these are the four types of parabola. Remember, again I'll tell you, parabola is an open curve. It's not a closed one. Alright, circle is one of the closed curves. Next, another type of a closed curve is an ellipse. Let's try to summarize ellipse. See, when you have an ellipse, this is the equation of an ellipse. X square by a square plus y square by b square is equal to 1. Now here, if a is greater than b, then you're going to have an ellipse, something like this, correct? Assume approximately like this. For this, the center is 0, comma 0, which is the origin. Then we have the vertex. So vertex is these two end points, isn't it? So end points are a, comma 0 and minus a, comma 0. Next, the two foci. So foci is going to be this point and this point. We write it as c, comma 0 minus c, comma 0, isn't it? But c is nothing but a into e. So foci is a, e, comma 0 or c, comma 0. Latus rectum. So latus rectum is going to be this distance, the perpendicular distance, 2b square by a. Then major axis, this entire thing is the major axis, which is 2a, or semi-major axis becomes a, and then minor axis is 2b, or semi-minor axis is b. Then we have the next type of ellipse, same thing. You are going to have an ellipse, but the ellipse is going to be like this, isn't it? So here a is less than b. Same equation, a is less than b. The center, the vertices are going to be different. So vertices are this and this. Then foci will also change. The latus rectum will change. length of the major and minor axis will also change. Clear? So this is another type of a closed curve, what we call as an ellipse. Ellipse is more of a general form of a circle, isn't it? So here the parameters what we have for an ellipse are these. Let's discuss the next and the last type of conic section. That is, let's discuss about hyperbola, the last one. So in hyperbola, see the equation. These are the equations. X square by a square minus y square by b square is equal to 1 is one of the hyperbola, what we call as a transverse hyperbola. And the transverse hyperbola, it looks something like this, where x-axis is the axis of symmetry, isn't it? So the center is 0, comma 0, isn't it? So the center is 0, comma 0. Then we have the vertex. Vertex is a and minus a. These are the two vertices. Then foci plus or minus AE. Remember we used to write it as C, comma 0. Then lattice rectum to B square by A. Same thing. Now here we have the transverse axis. Now remember, whenever we talk about the transverse axis, it is the distance from the center to the vertex. Correct? That is this distance. See, this is A. Okay, so this is A. So transverse axis is just A. Conjugate axis is going to be B here. This is B. Same thing if it's a conjugate hyperbola. That means if the hyperbola is something like this, then the whole thing is going to change, which is given by the second equation. Clear? So this is the equation for the hyperbola, or you can also say these are the parameters for hyperbola. But there is one very, very important thing which defines a conic section, that is eccentricity. So for every particular conic section, there is a type of there is a particular eccentricity. Now what is eccentricity? It is nothing but E is equal to, it is the ratio of the distance of the focus from the center to the distance of the vertex from the center. This ratio is what we call as eccentricity. So for a circle, eccentricity is 0 because the focus and the center, they coincide for a circle. That's why C is 0. So eccentricity becomes 0. Next, for an ellipse, it's between 0 to 1, some decimal value, positive decimal value. For a parabola, it is going to be 1. For a hyperbola, it's greater than 1. Alright, so for all the conic sections, this is the eccentricity what we have. Now, this particular video is going to summarize what you have learnt in this entire conic sections chapter. Every conic section and every parameter related to the conic section. Alright, so this completes the chapter conic sections.